So a supernova explosion is something where you see a star, which you hadn't seen before, suddenly turn billions of times brighter than it was. So it's an exploding star, and we think we know the energy for these stars comes from either nuclear energy, that is thermonuclear fusion, like a bomb going off for some supernovae, or from gravity, from the collapse of a star down to form a little nugget of a neutron star or even a black hole. Supernova 1987A, we think, is of this second kind. It's the kind that's powered by gravity, where the center of a star runs out of fuel, collapses in a fraction of a second, and then bounces and blasts its material out into the gas between the stars. So a supernova explosion is an exploding star. It's something that is the end of a star, and it's a tremendously energetic explosion.
The word of the day is evaporation. Is the change of liquid to gas in the water cycle. The gas is water vapor.
Bill Nye the Science Guy.
Hey, I'm in here. I'm in this giant freezer. Now, let's see what happens when I come outside where you are. See, the surface of my bubble helmet of science turns cloudy. That's because water vapor, which was floating around in the air, sticks to the cold surface in little liquid water droplets. Now, this process, this effect, this thing that happens is called condensation. It's the same thing that happens to people who wear glasses when they come in after being outside on a cold day. It's where clouds come from. Where'd you guys go? Oh, funny. Oh, very funny. Anyway, condensation is sort of the opposite of evaporation. Instead of liquid water gaining energy and becoming a vapor, water vapor loses energy and becomes a liquid. Little tiny droplets that stick to cold surfaces. It's a very important thing about condensation. Water vapor needs a place to stick in order for condensation to happen.
Look at the glass next time you drink your milk. Does it seem to sweat? Well, the glass isn't really sweating, of course, but it is wet. It's just the water vapor in the nearby air being condensed.
When clouds form, water vapor turns into tiny liquid water drops. But in order for that to happen, the water has to have some place to stick. It has to have something to stick to. So take a look at this. This is our big glass jug cloud apparatus of science. And we're going to make a cloud in here. First, we'll add a little water. This will be the water that will form our cloud. Just swirling it around a little. There. Now, using this pump, we'll pressurize the big glass jug. Then when I pull this rubber stopper off, the air in the jug will expand. And that's when a cloud should form. 3, 2, 1. See, nothing happened. That's because the water vapor didn't have anything to stick to. So what we're going to do is add some dust. Just a tiny amount of dust. And to make the dust, we'll use the smoke from these two matches. That's all the dust we need to form a cloud. Now watch. We'll pressurize it again. When I pull it off, the air in the jug expands. And when it expands, it cools off. The same thing happens to air masses when they get blown around by the wind and pushed up high into the sky. 3, 2, 1. See? It's a cloud. It's the water cycle. It's science.
Turn a ragtag, turn it on.
It might seem crazy what I'm about to say. Sunshine, she
coming.